Okay, 55. 55 is a radical. And when it's a radical, remember you take the expression inside the radical. Must be greater than or equal to 0. No negative. And so for x, this is 3x greater than or equal to 12 divided by 3 both sides. X is greater than or equal to 4. The domain, conclusion, domain of the function h is all real numbers such that x is greater than or equal to 4. One other word, bracket 4, comma, infinity. Okay, that was 57. Okay, 57 is f of x is equal to 4 over radical x minus 9. This is a combination because we have fraction and we have radical. The restriction is a compound restriction. Is when you set out the restriction is the expression in the denominator must be different to 0 and the expression inside the radical x minus 9 must be non-negative. Okay, solving this equation, so in this case square both sides, is x minus 9 must be different 0, x must be different 9, and this is x greater than or equal 9, positive 9. And so far the compound statement we have is we have x must be different to 9 and x greater than or equal 9. The conclusion, so the equivalent between this and this statement is obvious as x greater than 9 because this is a contradiction to this. So no equal and equal. When you combine this and que es intersection is greater than 9. So the domain of the function f is all real numbers such that x is bigger than 9, greater than 9. This is 57. Now 59. 59. Is similar because the only thing you should do is, for example, 59. 59 is p of x is equal to square root 2 over x minus 1. You separate, this is radical 2 and radical x minus 1. So this is a combination. Again, radical x minus 1 must be different to 0 and the expression inside the radical must be non-negative. Okay, square both sides, x minus 1 must be different to 0 and also x greater than or equal 1, and in this case x must be different to 1. The combination x different to 1 and x greater than or equal 1 is just equivalent to say x greater than 1. Therefore, domain of p of x is equal all real numbers such that x is greater than 1. 61. Okay, 61 is a little bit more complicated. Not too much, but it's complicated. Okay, the most important thing is you set out the restrictions. We have two cases. Capital F of t is a 61 is equal square root t minus 4. In the bottom we have 3t minus 21. In this case we see we have a radical and we have a fraction. So the fraction must be different to 0. And the radical gets t minus 4 must be non-negative. And we solve separately this compound inequality. This is 3t must be different 21 divided by 3, both sides. T must be different 7, and T is greater than or equal 4. So the domain is T must be different 7 and T greater than or equal 4. In other words, this is all real number line. This is 0, 1, 2, 3, 4, 5, 6, 7. This is greater than, so we have here a bracket incluye greater than or equal 4. In this case we have a whole. In this case we have the rest. Okay, entonces es domain is bracket 4, 7, parenthesis, union 7, infinity. This is the domain of f of t. Another way to express the answer is domain of capital F of t is x such that x is in between 4 equal to 4 and not equal to 7, or x is greater than 7. This is another way to express the same idea. Domain of f, and this is also domain of capital F. Okay? Okay, let's do 67. Okay, in this case, for the given function f and g, find the following for part A and D, so find the domain. First of all, you compute f plus g of x. It's the sum is radical x plus 3x minus 5. That's the expression. And find its domain. The domain is domain of f plus g is the only restriction that we have in the radical is x greater than or equal to 0. No negative here. Entonces es x such that x greater than or equal to 0. Okay, now subtraction. Subtraction is similar. The only difference is square root x minus, this is minus 3x plus 5. And the domain of f minus g is exactly the same. Now multiplication. F times g is radical x times 3x minus 5. Okay, you can, for example, multiply this and this is 3x radical x, and this and that is minus 5 radical x. And the domain is the same, because this expression inside the radical must be non-negative. And division f, division g is radical x over g is 3x minus 5. And the domain is different because we have two restrictions. To set out the restriction is the radical must be non-negative and 3x minus 5 must be different to 0. Is 3x equal must be different to 5 divided by 3. Now is domain of the division f division g is all real numbers such that satisfy two conditions: must be greater than or equal to 0, and also x must be different 5 or 3. Okay, that was the question 67. Now 68. Okay, again, compute f plus g is 1 plus 1 over x plus 1 over x. It's obvious 1 plus 2 over x. And the domain is oriented such that x must be different to 0. Because this denominator must be different to 0. Okay, now subtraction f minus g of x is equal 1 plus 1 over x minus 1 over x. Cancel out this and this. The answer is just 1, and the domain then is all real number. All real number. Now multiplication. Multiplication is multiply 1 over 1, no, 1 over 1, no. Multiply 1 plus 1 over x times 1 over x. This times this is 1 over x plus this times this is 1 over x squared. 1 over x to the second power. And again, it's obvious that the domain is all real numbers such that x must be different to 0. So above denominator, this and this, when you plug it in 0, it's undefined. And f division g of x is 1 over x divided by 1 over x. So LCD is x, here is x plus 1 over x. So it's x over 1 over 1, because this is cancelled out. This is just x plus 1. The domain, this is all real number.